All right, we're going to take a look at the Chapter 7 portion of the Spring Semester Review Packet. Question number 1, find the domain and range of this function. We can see that it's exponential growth. You're welcome to graph it. I went ahead and pulled up the graph here so you can see it if you're not sure what that's going to look like. Domain and range. Domain, what values of x can you plug in there? Well, there's no limit because the left side just approaches this asymptote, so it keeps going. The right side, it keeps going up, but it keeps traveling. So the domain is all real numbers, so that narrows it down to a or b. And then we can see it's growing above 0 rather than below, so we know that the range has to be y is greater than 0. So the only one that has both of those is option A. Number 2. Exponential growth, you look at the number raised to the exponent. So the 5 halves, the 0.4, the 1/8, and this is not even exponential growth. Notice the exponent isn't in, or the variable rather, is not in the exponent. So that's not exponential at all. So look at the base number. 5 halves is larger than 1, 0.4 is less than 1, 1/8 is less than 1. Growth is only when the base number is larger than 1, so it has to be f. Number 3, we can write both of these numbers as powers of 2. So 4 is 2 squared. 32 is 2 to the 5th. And so we already have exponents on both of them, so we need to distribute our exponents. So it becomes 4x plus 14. Over here I get 5x plus 15. Same base numbers, so now I know that the exponents have to equal each other, so I can state that 4x plus 14 is equal to 5x plus 15. So I will solve these now by moving all the x's to one side. I'll subtract 4x, and in the meantime I'll subtract 15 to move the constants to the other side. Negative 1 equals x, so x is negative 1, so B was the answer. Number 4, I can write both of these as powers of 3. 81 is 3 to the 4th, so this is 3 to the negative 4th since it was in the denominator, to the t. 243 is 3 to the 5th. So I have exponents to multiply again, so 3 to the negative 4t. Over here I have to distribute 5t minus 10. So you can set the exponents equal to each other now. Negative 4t is equal to 5t minus 10. I'll probably just subtract the 5t. Negative 9t is equal to negative 10, so I'll divide by negative 9. So I get negative 10 over negative 9. We can cancel out the negatives, so it's 10 over 9, which is G. All right, number 5. Here I can write them both as powers of 2. 2 to the 6th to the x is less than 2 to the 5th to the x plus 2. So to multiply the exponents, 2 to the 6x is less than, over here we have to distribute, 5x plus 10. So now I can write an inequality that 6x has to be less than 5x plus 10. Subtract 5x from both sides. So x has to be less than 10, so it has to be D. All right, number 6. Write in exponential form, so simply rewrite it. So the base number is 243, so that's going to be the base of the power. Then we jump to the other side. The 4/5 has to be its exponent, and then that isolates the 81. So 243 to the 4/5 is equal to 81. Looks like that's G. Number 7, we evaluate. Notice this log has been exponentiated on a 9. So we have 9 to the log base 9. Those are inverses. They will cancel each other out, so the 54 will be all alone. That'll be its answer. It will no longer be in an exponent. Number 8, I'm going to solve. So you could rewrite this in the other form to solve. You could exponentiate. I think it's probably going to be, it doesn't matter, maybe easier to just rewrite it. So 1/8 is the base number to the power of negative 1 is equal to x. Exponent of negative 1 just reciprocates it. So reciprocal of 1/8 is 8 over 1, so x is 8, so F. Number 9, solve. First of all, we know that you can't take a log of a negative number. So we know right away that there are some domain restrictions here. 7x minus 3 has to be greater than 0. So we'd add 3 divided by 7, so x has to be greater than 3/7. That's good to know. That's not our answer, but that's a stipulation that has to occur. I guess you can't see that very well. Let me try and write that bigger. So 7x minus 3 was greater than 0. Add 3 divided by 7, so x is greater than 3/7. That has to be true. When we look at the other one, similarly, it's x plus 12. That has to be greater than 0, so x has to be greater than negative 12. So we know that whatever we get for x has to be greater than 3/7, has to be greater than negative 12. If it's greater than 3/7, it's already greater than negative 12, so we kind of can ignore the second one. Now let's go ahead and look at the problem. They're both log base 2, so I can drop the log base 2, and we know that 7x minus 3 has to be greater than or equal to x plus 12. When I solve that, subtract x, add 3, divide by 6, 15 over 6. We can divide them both by 3, so we get 5 over 2. I don't know why I wrote an equal to. That should be greater than or equal to. X is greater than or equal to 5/2. I want to compare that to what I said about my domain. It has to be greater than 3/7. Well, if it's greater than 5/2, which is 3.5, it's already greater than those two. So that's going to be my answer. X is greater than or equal to 5/2. Looks like that's D. Number 10. I see we have two logs added together, so I'm going to have to condense them into a single log. So we have, since it's addition, we multiply the a and the a minus 8. So distribute that, we get a squared minus 8a is equal to 2. So now I can rewrite, or I can exponentiate, whatever your preference is. Maybe I'll exponentiate this time since I rewrote last time. So I'll do 3 to the left side equals 3 to the right side. That way the 3 and the log base 3 cancel. So I end up with a squared minus 8a, 8 squared minus 8a is equal to 3 squared is 9. I'll subtract that over so it's set equal to 0. A squared minus 8a minus 9 is equal to 0. I'll try and factor that. I'm going to have a negative 9 and a plus 1. That way they multiply to negative 9, they add to negative 8. So then my answers are positive 9 and negative 1, but I have to check and test to see if they're true because I'm taking logs of them. We can't take a log of a negative number, so you can't do log base 3 of negative 1. That's extraneous, I throw it out. 9 works in both cases, so 9 is the only answer. So H. Last problem on this page, number 11. 9 and 40, you cannot write them both in terms of the same base number. So we're going to have to log both sides. So I'm going to write log in front of the left side, the 9, but when I write log, the exponent gets to move in front. So 2n is freed out of the exponent. Same thing's going to happen on the other side. So I'm going to have log of 40, but then the 4n minus 7 can come out front. I'm going to have to distribute there on the right side. So 4n log of 40 minus 7 log of 40. I'm trying to get all the n's on one side, so I'm going to subtract 4n log of 40. So at this point, let me rewrite that. 2n log of 9 minus 4n log of 40 is equal to negative 7 log of 40. Okay, now I want to factor out the n because I'm really trying to get n by itself. So I end up with 2 log of 9 minus 4 log of 40 equals negative 7 log of 40. I can condense this together into just one single log. That might make the problem a little bit easier, especially since I'm running out of room. So the 2 can be an exponent on 9, so 9 squared, which is really 81, over, because this is subtraction, so we know this is over, 4 as an exponent on 40. So 40 to the 4th power, that's going to be a huge number. Maybe I'll just leave that as 40 to the 4th. Equals over here. Maybe I'll make that -7 an exponent. Okay, and so what I'm going to do to get in by itself is I'm going to divide by this whole log. So I'm going to take, I'll show you this on the calculator. So we're going to start with this log of 40 to the -7th. I might just put this all in parentheses, that might make it easier. Log of 40 to the power of -7. Divide by, and then I'm going to divide by this whole mess here. Log of 81 divided by 40 to the 4th. So log of 40 to the -7th divided by log of 81 over 40 to the 4th. And I get an answer of -0.008. Let's hope we find that. Oh, I made a mistake in there somewhere. I know the answer is actually A. I wonder where I made my mistake. Let me show you. Just let me pull up. I did it earlier. I didn't condense it. I think that I made my mistake in the last step when I condensed it. I had in. Okay, so I had everything the same in this case. What I did at this point previously was, instead of condensing it, maybe this would have paid off more, obviously, because I had the right answer before. I went ahead and divided by this whole mess. So then I divided this side. You can see I have it written out there. And then I just typed that in the calculator. Let me type that one in the calculator for you, and that one's going to get us the right answer. I'm not sure where I made my mistake, but I don't want to take time to figure it out. -7 log of 40 divided by 2 log of 9, let's see, minus 4 log of 40. 2.4922, there it is. Okay. So I'm not even sure the mistake I made before. I feel like it probably had to do with parentheses or something. Or maybe I condensed something wrong. But there's our answer, 2.4922. Sorry for that little mistake. Yep, we still got some more of Chapter 7, so let me flip to the next page. So this one's going to be similar, because 3 and 30 can't be written as powers of the same base. So I'm going to log both sides. That will move 5x minus 1 in front of the log. Log this side. I'm going to have to distribute. So 5x log of 30 minus, sorry, I don't know why I wrote 30. That should not have been 30. It should have been a 3. Minus the log of 3 is less than or equal to log of 30. So now I'll add log of 30. 3, log of 3. Giving me 5x log of 3 less than or equal to log of 30 plus log of 3, which I could condense just because I'm a little hesitant to condense just because I messed that up before. I can divide by 5 log of 3. Okay, let's try this out. Pull out the calculator so you can see. Parentheses around the numerator. Log of 30 plus log of 3. Oops. Oh man. Plus log of 3. Done with the numerator. Divide that by, I'm going to do parentheses, 5 log of 3. Hope we get an answer. 0.8192, and we know it's x is less than or equal to, so we get it, it's G. Okay, number 13. It says to use common logs. Honestly, I would just type this in the calculator. If you go to math and scroll down almost to the very bottom, there's a log base. Right there it is. We're supposed to do log base 9 of 72, so I'm just going to type it in like that. Let the calculator do all the work. 1.9464. Looks like C is the correct answer. Number 14 gives us the equation. We're depositing $1,000. Rate is 4%, 0.04. Time is 10 years. So I'll plug that in the calculator. 1,000 e to the 0.04 times 10, or that's just 0.4. 1491.82. That's F. Number 15, I'd probably just exponentiate using an e, because that'll cancel out the ln. So x plus 2 is equal to e to the third, so then I'll just subtract 2 from that. So I'll do e to the third minus 2 on the calculator quickly. E to the third minus 2, we get 18.0855, so B is the correct answer there. Number 16, I'm going to ln both sides so I can get rid of that e. So I get negative 9x. It's less than or equal to ln of 6. Divide that by negative 9. Since I'm dividing inequality by a negative, that flips my sign, so it should become x is greater than or equal to. We'll do ln of 6 divided by negative 9. Get about negative 0.1991. Looks like it's J. Number 17. They give us the equation. Half-life. So it doesn't matter what I start with, what my initial, I could say my initial was 100, and after a half-life it's going to be down to 50. It doesn't tell me those numbers. I can just make up numbers, but what I ultimately do is to divide by the 100. So I'll end up with 50 over 100, which is 1/2. That's what happens with a half-life. It's always going to be a half when you divide that away. Okay, and so now I'm going to ln both sides. And so I'm going to do ln of 1/2. I'll divide it by that, so type in ln of 1/2 divided by negative 0.0736, and I get t, which is 9.41, so about 9.4 days, which is B. Okay, number 18. At a wholesale food distribution center, okay, they give us the equation down here. Was 0.43 cents per pound initially. It's growing at a rate of 6.3%, 0.063. So from 80 to 17, that's 37 years. Let's plug that in. 0.43 times, oh, sorry, I did that wrong. 0.43 times 1 plus, I guess you can't even see this here, 0.063 to the power of 37. So 4.12, so F. And that is the end of the Chapter 7 portion.